Hello to everyone. We are Alex and Valeria from Amasty, Magento extension company in Belarus.
Alex is a Magento certified developer with more than 5 years of Magento experience. All this time he has been a part of Amasty team. He is our cocky, so to say, because he spent all his career in the same club.
Valeria is the head of QA department at Amasty. She's been into software testing more than 5 years, and she's also a testing instructor. How cool is it? But she's not always so serious-minded. Look, she drives this thing to work every day.
Together we are speaking about Magento Security today. Now, why is it so important? You may have heard about all kinds of fraud going on there, such as mass billing information theft from Magento stores in 2013, Kevin Mitnick attacks, and just random stories about stolen money online from your relatives and friends.
Frankly speaking, today we are talking from our own experience, not textbook. Some time ago, we did face with vulnerability in released Amasty extensions, but of course we have quickly fixed it, and the most important thing is that we learn from this point and made our extension even more secure. And when it comes to security, I always prefer to learn from the other people's mistakes.
We all work with Magento, our favorite platform of all times. Alex and I as a team Alex and I as a team are fighting these things every day. We have more than 200 extensions in our store, and every one of them must be secure.
Today you will learn about typical security breaches on Magento that can be useful for merchant, how to reveal them during the testing, QA engineers can find some interesting information, and how to avoid them during the testing, during writing code. Some helpful advices for Magento developers.
Now how to know what we are defending from. The list of popular vulnerabilities is available at Open Web Application Security project page. You will use it as a reference for all the points of our presentation.
In accordance with this list, here is the main vulnerabilities we are speaking of today.
And we are starting with the injections. Hackers have several ways of introducing or injecting code into your application. It is aimed at getting access to hidden or private information. The most popular type of injections is Sql Injection. It is aimed at getting access to a website database.
It is easier to look for things if you know what you're looking for, right? Same to testing. Here is the main patterns of Sql Injection you should be looking for. First, using guest, post, and other global variables without validation and processing. Second, raw SQL queries. Third, building parameters of where queries using concatenation. In such a condition, this variable can be unescaped and contain malicious code as a potential threat. And the same goes to order, join, group, and other SQL functions.
Let's roll. I've got a nice example. Here's what I found in the extension I was testing a couple weeks ago. The variable is taken straight from the username field. It means that you can add a quote mark, close the current query, and insert a new malicious one. It's a vulnerability. Let's see it in action. I went to the Magento admin login page and inserted an SQL injection code. We don't need to go through the code of this injection. What we need is to know that it creates a super admin with unlimited permissions.
You did it gracefully, but let me fix this code now. This is code what we had before, and as we told, is not good a style of coding when we create a SQL query with concatenation. Let's rewrite it. Now we pass the parameter to the Magento load method, and in the module it will be escaped by where function. You can see it here.
Awesome, but the parameters can be passed via injection not only this way. It can be done in the URL using get method. This vulnerability is similar to the previous one. The difference is only in the accepted data.
Yes, we know about this way and analyzed all the parameter passed to controller to close the security hole. Is the application secure now?
Alex, I get that irony. We haven't even started.
Oh.
Cookies can also be vulnerable to attacks. Here's what I found in the code. Yeah. The cookie parameter is passed to the collection and it's not being handled.
But we are setting this cookie before. We can try them, no?
Yes, but a hacker can still change it externally.
Oh, okay. We should always think about safety of our data. Let's correct this code. Now we just small change, but we let Magento know what is parameter it should quote. Have you got anything else?
Alex, are you telling me you trust the database contents, system configuration data, for example?
Yes, I do. It was already handled, and by the way, the admin set it there.
That's true, but here's a way out for a hacker. I found the following pattern in the code. Look, please. Say the site admin create a separate role with permissions only to a single configuration section. The user logs in there and inserts malicious code into the field. It is inserts. It is run by cron, and if it is executed, the user gets unlimited permissions and access to the whole and can do whatever he wants.
Oops, I get your message. Backend array must be secured too. Let's fix this. First of all, we add typization for this parameter, and next we pass this parameter to the query function with quoting.
As you shut this host down, I'm moving to file injections. On e-commerce stores, you don't meet file uploading that often, so it's easier to test all places with upload fields. Here's an example from a customer attributes extension. It has a single file upload field. I attempt to upload a PHP file instead of an image. If your attribute is not configured to accept only certain file extensions, I will be able to upload malicious files of any type. And after that, I will be able to run the file if I know where it is stored.
1 second. We can run the file.
Run the file. No?
Oh, oh. Run. Run. Yeah.
Okay.
Good shot, but not this time. Here's what you will see. What you will see. Magenta configured htaccess file to stop any running from the media folder. Yes.
And what if I upload my own htaccess with this piece inside?
Oh.
It lets me run the PHP file from the media folder. See yourself. See? See yourself.
No. No. No.
Some problems with the battery?
Maybe, but it changed.
He's going
Yeah.
to help us.
It's my credential for database. That is why she's the head of K department. But I'm used to fixing things. First of all, maybe.
No.
Oh, I forbid uploading PHP files. Then I block HT uploading, and finally I implement file uploading via Magento uploader that have already function to check file extensions.
But the hackers won't stop there. They will upload a JPEG file, but with a hidden piece of PHP code inside. Okay, if it is executed, they'll get access to the database. In case htaccess lets them do it, of course.
Sorry.
Let's get the previous file and add the following line into it. It allows us to run the code from the image. Using a special tool, say jhead, we change this Apple pig and leave some malicious code inside. Visually, the pig hasn't changed. Visually, the pig hasn't changed. If the get parameter exists, the result is access to the database. Now we just open this URL. Oops, I did it again.
Again. Yes, you did, but I know how to stop you. Let's look at the code for image uploader. Luckily, some awesome guys from Magento create a safe solution for it. We just need to use this function. It checks the code for acceptable file extension and resaves the image. Any malicious code will be removed at this point.
Good job. We have fixed all the main vulnerabilities connected with the injections. Now to the next point, cross-site scripting. While testing for XSS holes, it is important to pay attention to behavior patterns. Look for places where users enter data and other users are able to see it. I found the following pattern in the code. Say the sysadmin created a separate role with permissions for a single configuration section.
Sorry.
Something with the slides?
Yes.
Тык назад сделай.
Sorry. If we had simple example, if the controller has the code like this, and the modules view have the code like this, most probably this code wasn't handled. And if it contains some malicious code, it will work.
Let's see how it goes in real life. I'm going to test the custom forms extensions. It collects the user's data and lets the admin see it in the backend. I put some JavaScript code into the field of the extension, and this code contains a link to an image, and I have an access to a server where it is stored. Now, using the document cookie function, I get the user cookie and pass it as a get parameter to the picture location. As I submit the form, the admin sees our message in the submitted data backend area. This message doesn't look suspicious, but his cookies are already stolen. Now we can get the stolen cookie from the access log of my server. And if I add this stolen cookie to my browser for the compromised website, I'll get the access to the admin panel without logging in. So bad.
That is why the store administrator should make the cookie HTTP only. But if they didn't do it, we should still protect our form. Let's handle all output values with escape HTML function. It will replace all HTML tags with special chars. And by the way, if you need to output HTML, you can pass allowed text as a second parameter to this function.
Okay, I see that you have protected the admin user, but what about customers' personal data? Now I'm going to show you a quick way of getting money. Take the shipping table rates extension. This extension lets merchants to add their own shipping methods. Insert some code into the comment for the shipping methods, and it lets you to get access to customers' credit card data. Now, when a customer buys something on this site, you can get the credit card data, hear the alert, and buy anything you want, even an Amasty extension.
Basically, this means that we should protect our users from admins too. And in this case, the technique for shutting down the vulnerability will be exactly the same as in the previous case.
If you're not overwhelmed, let's dissect the next point. Insecure direct object references. It happens when a random user gets access to files he shouldn't even know about. Let's see how it goes on Magento.
As everyone knows, Magento stores config files, login and password in a local.xml or env.php file. If the hackers get his on it, he will have access to the database and basically to the whole site. Let's check the code that generated link for downloading. This is a pattern. Now, to generate and file path parameter, the request parameter is used without any validation, as you can see. And if we pass the file name like this, it will be merged and give us the config file.
Let's torture another extension which lets merchants add a file upload field to their customer's account. I'm going to download a file with a picture there. Now, as you see, we have a generated URL, and the file is a parameter in it. Using any developer's console, let's replace this parameter with our own code transformed with the URL encode function. Now we have the following URL. Just one click, and we got the configuration file and access to the whole site. Wow.
But how to fix this, long story short? Just to add functions that correct file name. Look, we can only replace the special chars with underscore. This is what I call wow.
Okay, we are getting serious here. Say the site stores a document for each customer using the same URL pattern. In this case, a simple brute force session and some logic let you get access to files from all the customers.
War is war. On the Safe Magenta store, this link should look like this. In the controller, we can decode a file name, and it can help us with brute force and check customer permission for this file.
As you see, we are a great team. Now to the next important point of Magento Security. You have to pay special attention to Magento API Workflow. If you look at Magento 2 checkout, you'll see that Magento API Workflow is using even more these days. But API is another entry point for bad guys. What do you say, Alex?
That is right. Firstly, I would like to mention the correct file permission, to correct permission to the API section, ACL resources to be extracted. If you don't have them, we have the example.
Yeah, I have an example. Say you've created an API without resources section, and it creates an order. Using this hole, a hacker can create an unlimited number of orders and empty your stock quantity in a minute, so customers won't be able to buy from you.
And secondly, you have to remember that Sql injection and XSS data can be passed by API too. It means that please apply the pattern mentioned above while you write in code for APIs. And of course, we have covered now only the part of existing vulnerabilities for e-commerce platform, but our time is running out. And before wrapping it, I would like to mention some other significant points. Please don't forget them. First, install your security patches in time. Each well-known vulnerability is fixed by Magento. Use additional backend measures like HTTPS connection, firewalls, and IP restrictions. Check if user and admin password are strong enough. Use different security extensions like, for example, Amasty admin actions log. Configure your server for safety. And when you buy extensions for your store, always pay attention to security measures.
And here are the points to build your testing process upon. First, look for known patterns, as we mentioned above. Then check forms, URLs to prevent SQL and JavaScript injections. Then check user cookies. Make sure admin area has no security holes. Test files uploading via file upload inputs. Look for unwanted. Let them see it. Look for unwanted access to users' data via direct links, and don't watch hacker movies. I've been there.
Yes, and here is my tips how to write in safe application on Magento. First, validate all incoming data. Use data typing and check for confidence limit. Data escaping is a must, as you can see before. Check your extension for getting access to important files, for example, local.xml. Data validation for API is a must too. Use Magento functions. They are awesome and usually they are protected. And make sure that your server environment is configured for safety. And of course, you should think, and think again. Think like a hacker when you are coding different extensions for your Magento store. And please know that during our presentation, while we demonstrated different vulnerabilities with our extension, it was only an example. All our extensions are deeply tested and are the high of the security.
Okay, that's a wrap for today. We have introduced the main vulnerabilities your Magento store can have and explained how to fight them. And mind that proper coding and mindful testing aren't so complicated, but having a Magento store without these vulnerabilities is a key factor to store success. Stay safe.
Thank you so much for your attention. Now we're ready for your questions. Whoa, 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 whoa. Someone hacked you.